And so, as you can hopefully tell from my example, Hubble's law would be true from anywhere. If you lived in the Andromeda Galaxy, you would see the same thing. I like this example here showing coins on a balloon instead of me just drawing them on there to give you the same idea that the coins would move apart twice as fast if there was twice as much balloon material separating them. And then, of course, the other big thing that we learned from that demo was that there is no center of the universe. It's one of the most common questions I get. There is a point in time when it all began, and we know when that was, 13.8 billion years ago. I like the raisin bread example, as I mentioned, the expanding raisin bread, the raisins being pushed apart, and so forth. Now, as space expands, one interesting phenomenon that's a result of this is called the cosmological redshift. I think it's worth mentioning here. Take a look at the balloon at the bottom of the screen. You start out with a kind of blue shorter wavelength here, and as the balloon expands and as space expands, that wavelength actually gets stretched out. And so we think this has happened over time in the universe, that the original high-energy radiation, when the universe first formed, has been stretched out into longer wavelength, lower-energy radiation. And that is going to lead us into the next section, because that was going to be the proof of the Big Bang Theory, an incredible moment in the history of astronomy and a true milestone in science. We'll get to that next time. Thanks for listening.